pushing apart. Amazing magnets. Magnets have the amazing power to make things move. When strings pull and lift things, it's easy to see how they work. But magnets seem to make things move by magic. Watch a paper clip scoop to a magnet. The paper clip slides along as if pulled by an invisible string. Magnets pull only on special kinds of metal. So we try to move a steel spoon or an iron nail with a magnet. Now try a ball of cotton, a rubber ball, or a plastic pin. So only special things will be attracted to magnets. How do magnets work? Magnets can only pull on things that are close enough to them. Put a paper clip far away from a magnet and slowly move the paper clip closer and closer. How close does it get before it leaps toward the magnet? So here's my paper clip and here's my magnet. It's too far away, right? So if I get closer and closer, watch. It should. You see it move to it? Yeah. Yes. Now if it's a stronger magnet, I wouldn't even have to get that close. That one you have to get pretty close. Let's see if I can get one of my bar magnets and see if it's stronger. Let's see if one of my bar magnets is stronger.
I think they are. What if you try both of them?
Okay, let's see.
If you try both of them, maybe it might work.
Ah, it's about the same. But it jumps to it. I didn't even touch it yet, and then it jumps to it. It moves to it. Because once the field gets close enough to the magnet, then it attracts it. Okay, magnets can work through a covering, even if it's thin enough. Lay a sheet of paper over your magnet and place the paper clip on top of the paper. Or try putting a piece of plastic wrap or the corner of your shirt on top of the magnet. What happens to the paper clip now? We'll do that in an experiment next week. We'll see if it can work through paper. Dangle an iron nail from the end of a magnet. Now touch a paper clip. So if you put a magnet to a nail, it makes the nail become a magnet, and then it will pick up a paper clip with the nail. It transfers it. The nail has become a magnet. When some metal objects touch or get close enough to magnets, the metal objects become magnets. So you can pull the nail away from the magnet, and the paper clip will still sometimes stick to the nail if it has enough magnetism to it. Rub a steel spoon along a magnet. You can feel the spoon being pulled toward the magnet's ends. These ends are called, what are the ends called? What? North and south pole. Poles. They're called poles. A magnet's power is strongest at its two ends. One end is called the North Pole. The other end is called the South Pole. What else do you know that has a North Pole and a South Pole? Wyatt? The world. Did you know that the Earth is a giant magnet?
Yeah.
Yes, it has a giant magnetic field around it, and it's strongest at the North and the South Poles on the Earth. If you break a magnet apart, you have two new magnets. Each separate piece has its own north and south. So this was one magnet with a north and a south, and they broke it, and now they have one. But you can only have one on each magnet. You can't have two north poles or two south poles. You only have one of each. The poles of a magnet can push as well as pull. Poles that are the same or alike repel each other. Remember, repel was one of our words we did yesterday. That means to push away. Repel. The pole of one magnet will push away from the north pole of another. Fun fact, in Japan, some high-speed trains use extra strong magnets. Magnets on the train repel or push against magnets on the track, and the track seems to glide on a cushion of air. So they use magnets to make the trains go in Japan. Opposite poles attract each other. One magnet's north pole will stick to the south pole of another. Remember, that is called what? When they go away from each other, it's called pale. When they go towards each other, it's called?
Magnetic.
Attract. Who said attract? Very good. Attract. That's right, Lily. Attract. Magnetic Earth. We were just talking about this. Earth is a giant magnet. It has two ends or poles just like other magnets. Earth's magnetic ends are close to the north and the south poles that are shown on a globe or a map. The cold North Pole and South Pole covered with ice are not the same as Earth's two magnetic poles. So the actual north and south poles that are cold are not the actual magnetic north and south. How does a compass work? Earth's magnetic power pulls other magnets. The needle on a compass is a tiny magnet. So the needle on a compass is a tiny magnet. The needle always lines up in a north-south direction, pointing toward the magnetic poles of the Earth. A compass won't work if you are standing too close to the cold North Pole. That's crazy. The needle points to Earth's magnetic pole. Once you travel past that magnetic pole, the needle does not point northward anymore. I don't think we have to worry about getting too close to the North Pole here or the South Pole. A compass shows us what direction we are moving in, north, south, east, or west. Sailors once used compasses to cross the ocean and find their way back home. So I have a compass here. You were asking me what was in these boxes yesterday. There is compasses in here. Now remember, the magnet is inside. The needle is a magnet, and it points to the North Pole of the Earth, and that's how it tells me what direction this is. So if I'm holding it like this, and I'm going this way, it tells me it's pointing to the west. W is west. We're going to learn directions. I'm going to learn when we learn about maps. It's kind of hard to see. Yeah, there we go. See how the pole's moving? So if I was facing the south, it would be pointing to the S. If I was facing the N, it would be pointing to the north. So that's called a magnet. Okay? All right. So that's a compass. We'll look at those closer next week when we are doing our experiments. Magnets all around. Some of Earth's rocks have magnetic powers. Long ago, the Greek and Chinese people discovered the rock magnetite. Another name for a piece of magnetite is a lodestone. Lodestones were used to make the world's first compasses. So there's actually rocks out there that are magnets. The Greeks were amazed as they watched magnetite pull small pieces of iron. The ancient Chinese hung splinters of magnetite from strings and watched the rocks line up in a north-south direction. Today, now here's all the things that have magnets. Electric fans, when they whirl, that's used by using a magnet. When you hear a refrigerator hum, it's using a magnet. And burglar alarms ring with the help of magnets in their motors. Huge magnets help junkyard workers lift cars. Have you ever seen that, where they lift cars, maybe on TV or in a book? These magnets move cars and trucks as if they were small toys. Doctors also use magnets in special machines to look inside your body, like x-rays. Magnets push and pull us all around the world. So, that's more about magnets. So today, we're going to see what is magnetic in our room. We're going to investigate the room and decide what is magnetic in the room. So before we do that, make sure you have your thing cut out. I cut it around the side. I folded the little flap over, and I cut here and I cut here. And then I glued down this part, and now I have 3 flaps. And what we're going to do is we're going to draw lines to help us remember. So shut this, or open this flap and put a line here. And then open this flap and put a line here so that you have the lines for your flaps underneath them.
And some things could have metal inside them.
Okay, so on the first one it says predict. Remember, predict is when we guess. We use a guess using our schema, what we already know, and what we've learned. What things in the room do you think will be magnetic? What's something that you think in this room will be magnetic, Emma? The file cabinet? Okay, I want you to write 3 to 5 things right here. Don't go past your line. 3 to 5 things that you think are magnetic in the classroom. We already did 1. 3, 4, 5 things. You can write more than 5 if you want. But at least 3. Yes, Sadie. We already picked 1. File cabinet. Now I want you to pick at least 3 more things. All right, so now you've listed at least 3 more things on here.
I did 4.
You can do 4. That's fine. You can do as many as you want. Now in the next section, I'm going to give you a wand, and you're going to go around the room, and you're going to try things out. It can be more than what you just wrote there. It's up to you. So say I didn't write the air cleaner up here, but I want to try the air cleaner. So what you're going to do is you're going to write some of the things. You don't have to write all the things, but I want you to at least do 5 things that you tried in the classroom, okay? So I'm going to try the air cleaner, and you can write this one if you want.
Me too. Me too.
And then you're going to put ... and you're going to put yes or no, like that, okay? So I'm going to try the air cleaner. Does it stick? No? It doesn't, so I'm going to say no. And I want you to try at least 5 things. And you're going to write the name of it and put ... and say yes or no, okay? Can you do that? 5 things. In the classroom, you can do as many as you want, but you only have to write 5 of them.
Can we write more
Okay.
than 5?
You can write more than 5 if you have room. Just got to make sure I can read it, right? We're not going down here yet. This is for something else. So this is only in the middle. Only in the middle. So write as many as you can fit, and then at least 5, right? Because I'm going to count 5 when I grade. I'm going to count for 3 up here and 5 in the middle when I grade the paper. Okay, so I'm going to bring you a wand, and you can go around. You are not allowed to come over here. Okay? Not by my desk. When I grade it, I'm going to look for 3 or more up here, and then I'm going to look for 5 or more things you did down here, and you have to put yes or no next to it, whether it was magnet or not. Now, at the bottom is a wonder. What are some things outside of the room that you want to test? So I want you to write 3 things that are maybe in the hallway or outside, on the playground, or in your house that you would like to test with the magnet, that you wonder about. I wonder if they're magnetic. It could be anything outside this room in the whole world. Write 3 or more things here that you wonder about if they're magnetic. I'm looking for 3 or more.